Now the next topic is single step methods. Single step methods. Here these methods are used to solve first order initial value problem. So consider you write like this: the methods for the solution of initial value problem u dash equal to f of t comma u with what condition? With the initial condition u of t naught equal to some u naught or eta naught, okay, where t belongs to the interval t naught is the starting value and b is the end value. This is equation 1. Okay, what is the differential equation? U dash du by dt equal to f of t comma u with the u of t naught equal to eta naught. And what is t? Belongs to the interval t naught comma b. T naught is the starting point, and b is the terminal point. Can be classified, the methods to solve initial value problem can be classified into two types. The first one is single step methods, and second one is multi-step methods. I already explained this, but once again, multi-step methods. Now in single step methods, what a single step means, I told you j plus 1th solution is obtained by jth stage only. So in single step methods, the solution at any point is obtained using the solution at only the previous point. Yes, exactly, j plus 1th stage solution obtained by jth stage only. Hence a general single step method can be written as uj plus 1 equal to j plus 1 solution is obtained from jth stage solution h into some function of what? Tj plus 1, tj, uj plus 1, uj, h. This is equation 2. What is that? J plus 1th solution is here and also here, right? But j plus 1th solution can be taken in terms of jth solution. Now single step method general formula is this one, equation 2, where phi is called function of arguments, where phi is the function of the arguments. What are the elements here? tj plus 1, uj plus 1, and h, and also depends on the function f, right side function f. Okay, generally we often write it as phi of t comma u comma h, simple notation. And the function phi is called increment function. The function phi is called the increment function. Now if uj plus 1, j plus 1th solution can be obtained simply by evaluating the right hand side of equation 2. Then the method is called explicit method. Then the method is called explicit method. Explicit method means j plus 1th stage obtained from jth stage, then it is called explicit method. In this case the method is of the form how to write the explicit method. Uj plus 1 is depends on what? Jth stage only jth stage only. Phi of, so I will write only tj, uj and h. This is explicit method and also called as single step method. But if the right hand side of equation 2 depends on uj plus 1 also, then the method is called implicit method. That means on this right side there will be uj plus 1. Okay, then left side uj plus 1 and on the right side also uj plus 1, then method is called implicit method. Okay, and its general form is given by equation 2 itself, because in equation 2 on the left side and right side both uj plus 1 terms are there. Okay, and the next one local truncation error. Or it is also called discretization error. What is the definition? See, the exact solution u of tj satisfies the equation. What is the equation? Our single step method equation, uj plus 1. In place of uj plus 1 write u of tj plus 1 equal to uj. In place of uj write u of tj plus h into phi of what? This is tj plus 1 comma tj plus 1 comma tj, u of tj plus 1 next u of tj comma h plus the truncation error tj plus 1 error. Okay, when I substitute in the approximate the numerical method, the exact solution is substituted, then definitely you will get one error term. What is this error? In the numerical scheme, if I substitute the exact solution, definitely it is not satisfied, so there must be some error. That error is called tj plus 1, where tj plus 1 is called local truncation error of the method. Therefore, what is tj plus 1 is equal to? Tj plus 1 is u of tj plus 1 minus u of tj minus h into phi of tj plus 1 comma tj, u of tj plus 1 comma u of tj next comma h. This is local truncation error formula. Next one is order of the method. This is important definition. What is order of a method? The order of a method the order of a method is the largest integer. What is this? Largest integer p for which modulus of 1 by h of tj plus 1, truncation error divided by h, it must be equal to capital O of order of h power p, this is the definition. What is that? After getting this truncation error tj plus 1, divide it by h, then you will get something h cube or h power 4 like that, then order of h power p, then this p is called order of the method. Now first method, Taylor series method. First single step method is Taylor series method. Assume that the function u of t can be expanded in Taylor series. You know what is a Taylor series expansion in real analysis? Taylor series about any point tj, that is u of t equal to about the point now, so tj, u of tj plus t minus tj u dash tj plus t minus tj whole square by factorial to u double dash tj and so on, plus pth term 1 by p factorial t minus tj whole power p u pth derivative of tj. Okay, and the next p plus 1th term, last term, if I consider last term, p plus 1 factorial t minus tj whole power p plus 1 u p plus 1 of tj plus theta h, this will come in reanalysis. Okay, tj plus theta h, and this expansion is valid. This expansion holds for all t belongs to what interval? Our interval t naught comma b. And what is the value of theta? 0 less than theta less than 1. Theta lies between 0 and 1. Do you remember in reanalysis we are getting Lagrange's form of remainder, Cauchy form of remainder using Taylor series? Okay, that's the context. Now substituting t equal to tj plus 1, in equation. This is, take this as equation 1 2 3, take this as 1, let us take 1. Substituting tj plus t equal to tj plus 1 in equation 1, then what 1 comes given as u of tj plus 1 equal to u of tj plus, what is this becomes, this term tj plus 1 minus tj, that is h. Okay, I'm giving here h equal to tj plus 1, h equal to tj plus 1 minus tj. Okay, so h into u dash tj plus h square by factorial to u double dash tj and so on, plus what is the pth term, 1 h to the power of p by p factorial u pth derivative at tj, and this is h to the power of p plus 1 by p plus 1 factorial u p plus 1th derivative of u at tj plus theta h, The next step is u of tj plus 1 is equal to u of tj plus, I will write except p plus 1th term, let us club all the terms in the function phi, tj comma u of tj comma h plus the p plus 1th term h power p plus 1 by p plus 1 factorial p plus 1th derivative of u at what point? Tj plus theta h. Tj plus theta h, where what is the increment function? H into phi of tj comma u of tj comma h is equal to what? H into u dash tj plus h square by factorial to u double dash tj up to what? Pth term, h to the power of p by p factorial u pth derivative at tj, u pth derivative at tj, right? Now you write the value as, therefore this implies uj plus 1 is equal to what? Finally uj plus 1, I will write like this, and u of tj uj plus h into what? Phi of tj comma uj comma h, tj comma uj comma h, equation 2. This is equation 2 for what values of j? 0 1 2 up to n minus 1, 0 1 2 up to n minus 1. Okay, this is what single step method as usual. Okay, the error or truncation error of the method is this is Taylor series approximation. This is Taylor series approximation, and phi is what? This expression h into phi of is up to pth term. The error of the method is, what is the local truncation error? Tj plus 1 equal to the p plus 1th term is the error. This term will be the error. H to the power of p plus 1 u p plus 1th derivative of tj plus theta h. This is the remainder term or error term. Okay, equation 2 is called Taylor series method. One can substitute that phi function directly, you will get this one. When p equal to 1 means what? H into u first derivative. When p equal to 1, what is 2 becomes u j plus 1 equal to uj plus only first derivative you will get u dash j. But what is u dash means? The function using the differential equation. What is this? Tj comma uj, which is Euler method, right? When p equal to 1, Taylor series method becomes Euler's method. Okay, now to in equation 2 in phi, how many derivatives are there? Double derivative, triple derivative, and pth derivative. In phi, the derivatives, what are those derivatives? U double dash, u triple dash, and so on, u pth derivative are calculated by using the differential equation u dash equal to f of t comma u. Differentiate this one. Okay, u dash, one time differentiation, u double dash, next u triple dash, u, and so on. So using the differential equation, we calculate all the derivatives, and those are substituted in Taylor series formula. And next one, the error h to the power of p plus 1 by p plus 1 factorial. The error is equal to h to the power of p plus 1 by p plus 1 factorial p plus 1th derivative of u at tj plus theta h is this is the error. Okay, this is the error term. If the error is epsilon, the number of terms included in formula, you write like this: the number of terms, p terms are there in equation 2, the number of terms included in equation 2 is fixed, maybe 2 terms, 3 terms, or p terms fixed by the permissible error. If this error is epsilon, and the series, I'm taking permissible error as epsilon, and the series is truncated, series is truncated. Truncated means cutted. Cutted at the term up of tj means Taylor series is considerable up to pth order derivative. That means Taylor series of order p only. Order p only. Then what is this error? H to the power of p plus 1 by p plus 1 factorial up plus 1 of tj plus theta h. Theta h, this modulus is less than epsilon. This is the maximum error. So this implies h to the power of p modulus of this derivative at tj plus theta h is less than or equal to p plus 1 factorial into epsilon. P plus 1 factorial into epsilon, isn't it, right? So here we assume that or one can write like this. This is h to the power of p modulus of fp of tj plus theta h is less than p plus 1 factorial epsilon. That means I am replacing p plus 1th derivative by function p. Why? Because here u dash equal to f, u double dash equal to f dash, like that. So u p plus 1th derivative is nothing but fp. So I have replaced p plus 1th derivative using pth derivative of the function, and here we assume that this is known value. The modulus of fp of tj plus theta h is known. Therefore, for a given h and epsilon, the error equation, the previous equation, the error equation will determine p value, and if p and epsilon are given, then it will give an upper bound on h. So from the error equation, if h and epsilon are given, then I can find p value. If p and epsilon are given, I can find bound on h. Now the next point is, this is important, since tj plus theta h is not known, right? This is obviously is not known. Then how to find the value of this one, f of tj plus theta h? We observe the modulus of this function is replaced by, how it is determined, is replaced by its maximum value in the interval t0 comma b. In every error we have considered this. What is that? If this value is not known, the pth order derivative of the function having maximum value in t0 b, that was replaced. Now this is important, this point. A way of determining this value, how to determine this maximum value? See, the way of determining this value is as follows. How to evaluate this error term is as follows. What is this? Write one more non-vanishing term. In the series. One more non-vanishing term in the series that is required, and then differentiate this, series p times. The maximum value of the maximum value of this quantity, in T naught comma b gives a rough required bound. So I will explain this point in the problem. Now, based on Taylor series, see one problem. Given the initial value problem, u dash equal to t square plus u square with a u of 0 equal to 0. Determine the first three non-zero terms. In the Taylor series. Determine the first three non-zero terms in the Taylor series for u of t and hence obtain the value for u of 1. Also determine t when the error in u of t obtained from the first two non-zero terms is to be less than 10 power minus 6 after rounding. 10 power minus 6 after rounding. Solution. First, let us write the Taylor series expansion up to what? The first question, up to first three non-zero terms. The Taylor series of u of t about what point? The t, about t equal to t naught equal to 0 up to 3. Okay, let me write or don't write up to, because how many non-zero terms we will get we don't know. The Taylor series of u of t about t equal to t naught is, what is the formula? ut equal to u of t naught, right, plus t minus t naught into u dash t naught plus t minus t naught whole square by factorial 2 into u double dash t naught plus t minus t naught whole cube by factorial 3 u triple dash t naught, and so on. Take this as equation 1. Now one by one, what is the first given u of t naught? What is that? U of 0, that is given as 0. Next, u dash t is what? T square plus u square. So u dash of t naught is what? That is u dash of 0, right? T naught, or I can write like this: u dash of t naught is t naught square plus u naught square. T naught square means 0, u naught is also 0, so this value is also 0. Next one, u double dash t. Differentiate this. This is 2t plus this is 2u u dash. Okay, so u double dash t naught is what? 2t naught plus 2 u naught u dash naught. So t naught 0 and u naught is also 0, so this is also 0, right? And coming to u triple dash, what is u double dash? Once again I will write u double dash is what? 2t plus 2u u dash. This implies u triple dash t is equal to, this is 2 plus uv method 2 u dash plus 2 u double dash u and v. Okay, now u triple dash t naught is equal to what? This is 2 plus 2 u dash naught square, right, plus 2 u naught u double dash naught. So this value 2 you will get, and remaining everything is 0. Now u fourth derivative. For this, let us write one more. 2 derivative 0, and this is 2 u dash. Okay, let me write once again. This is third derivative. U triple dash t is what? 2 plus 2 u dash square plus 2 u double dash. So u fourth derivative is what? This is 4 u dash. 4 u dash, isn't it? 2 derivative 0, 2 into 2 u dash, and u dash derivative u double dash, plus this is 2 u dash u double dash plus 2 u triple dash. So 6 u dash u double dash, right, plus 2 u double dash triple dash. So u fourth derivative of t naught is equal to what? 4 u dash, sorry, 6 u dash naught u double dash naught 2 u naught u double dash naught. So this entirely 0. Now coming to fifth derivative. Take one more derivative for this. So this is 6 u double prime uv method, u and v, and 6 u dash common. Now u double dash derivative triple dash. Coming to next one also, u 2 u dash u triple dash plus 2 u fourth derivative, right? So u fifth derivative t naught is equal to if I substitute, let me write here, fifth derivative t naught equal to first double derivative 0, first derivative 0, u 0, so totally 0. Now u sixth derivative, any common terms are there? Let us see any common terms. This is u fifth derivative is these two are same, so let me write u double dash square 8 u dash u triple dash 2 u fourth derivative, right? Therefore u sixth derivative t equal to u sixth derivative 12 u double dash u triple dash plus, now uv method, 8 u double dash u triple dash 8 u dash u fourth derivative plus 2 u dash u fourth derivative plus 2 u fifth derivative, okay. If I substitute u6 t naught, this becomes also 0, right? And what are the common terms here? This is 18 plus 12 plus 8, 20 u double dash u triple dash, and these two are same, 10 u dash u fourth derivative plus 2 u fifth derivative. Now one more seventh derivative. Why I am writing this? Because this is 0, this is 0, this is 0. I need 3 non-zero terms. Now all these are zeros, so only u double dash is non-zero. Okay, so I have to calculate all these derivatives. Seventh derivative is what? You will get seventh derivative for this. 20 u triple derivative plus 20 u double derivative u fourth derivative plus 10 u double derivative u fourth derivative plus 10 u dash u fifth derivative plus 2 u dash u fifth derivative plus 2 u sixth derivative, then u seventh derivative at t naught, u seventh derivative at c naught, this value is 80. Now u eighth derivative at t, and similarly u ninth derivative at t naught, u 10th derivative at t naught, up to 10th derivatives are zeros. And what is the 11th derivative? 11th derivative is 2u 10th derivative plus 20u dash u 9th derivative plus 90u double derivative u 8th derivative plus 240u triple derivative 7th derivative plus 420u 4th derivative and the 6th derivative, 4th derivative and 6th derivative plus 252u 5th derivative whole square. From this is u 11th derivative. U 11th derivative t naught is equal to what? The value 38400. 38400. Therefore, equation 1 becomes, what is this one? U of t equal to u of t naught plus t minus t naught u dash t naught t minus t naught whole square by factorial to u double dash t naught and so on. What is the last one? I am taking t minus t naught whole power 11 by 11 factorial u 11th derivative at t naught and so on. So this u of t is equal to the first term 0, u dash 0, u double dash 0, and coming to u triple dash t minus t naught whole cube by factorial 3. What is u triple dash formula? This is 2. Next, 4th derivative 0, 5th derivative 0, 6th derivative 0, right? 4, 5, 6, 7th derivative t minus 0 whole power 7 by 7 factorial. 7 factorial, what is the 7th derivative? 80 plus 9th 0, 10th 0 and 11th one t minus 0 whole power 11 by 11 factorial. 11th derivative is 38400. Now how many non-zero terms are there? How many non-zero terms? 1, 2, 3. So getting up to 3 non-zero terms plus and so on. Non-zero terms are enough. Therefore, what is u of t up to 3 non-zero terms? After simplification, t cube 1 by 63 t power 7, 2 by 2079 t power 11. This is the expansion. This is 2. Now what is the given value? I need 1, u of 1 value. 1 by 3, 1 by 63, 2 by 2079. Okay, this is 0.350168. 0.350168. Now the question is, see, the another question is also what? Also determine t. Now I am giving, now we have to determine t when the error in u of t obtained from first two non-zero terms is to be less than how much? 10 power minus 6 after rounding. Now see, this is the Taylor series expansion up to 3 terms, but what is the required? Up to 2 non-zero terms. Okay, right. The Taylor series up to 2 non-zero terms is u of t equal to t cube by 3 plus t power 7 by 63. And what is that? The error in u of t from first non-zero term. Therefore, the error after two non-zero terms is what is the error? 2 by 2079 t power 11 is the error. And given that error is less than how much? Less than is to be less than 10 power minus 6. That implies 2 by 2079 into t power 11 is less than 0.5 into 10 power minus 7. 0.5 into 10 power minus 7. This is what you call if 10 power minus 6 accuracy is needed, then take it as 0.5 is compulsory and decrease 1 unit, or simply if 10 power minus 4 accuracy is required, then take 0.5 into 10 power minus 5, like that. This is the idea in after rounding means. So what is this? From this, this is t power 11 is less than how much? 0.5 by 2 into 2079 into 10 power minus 7. By trial and error, you will get t value as 0.41. Okay, this is one model problem. Next one, Runge Kutta methods. For this, consider the initial value problem. U dash t is equal to f of t comma u with condition what? U of t naught equal to u naught. This is equation 1. Integrating equation 1 on the interval tj comma tj plus 1, we get integral tj to tj plus 1 u dash t dt is equal to integral tj to tj plus 1 f of t comma u dt by the mean value theorem of integral calculus. By using the mean value theorem of integral calculus, we get this is what, anyway, from this I can write this is integration and derivative gets cancelled. So u of t between the limits tj plus 1 and tj. So I can write u tj plus 1 minus u tj. Take that u of tj onto that side, u tj plus integral tj to tj plus 1 f of t comma u dt. Now that this integral is evaluated by mean value theorem of integral calculus. Then what I am getting, u of tj plus 1 equal to u of tj plus h into, h means the difference between tj and tj plus 1, h into function value in place of t, tj plus theta h, in place of u, u of tj plus theta h, where theta lies between 0 and 1, this is equation 2. Okay, and let us see one by one case. When theta equal to 0, case 1, when theta equal to 0, we get 2 implies what? u j plus 1, u of tj plus 1 equal to u of tj uj plus h into f of tj comma uj, which is Euler's method, right? Euler method. And second case, when theta equal to 1, what I'm getting, this is uj plus 1 is equal to uj plus h into f of tj plus h comma u of tj plus h, right? That is equal to uj plus h into f of I can write this is completely tj plus 1. Tj plus 1 stands for tj plus h, uj plus 1 stands for uj plus 1. This is which is backward Euler's formula. This is backward Euler's formula, backward Euler method. Okay, now let us approximate. I will not go to theory to confuse you. Let us take third approximation, third case. When theta equal to 1 by 2, then uj plus 1 is equal to, equation 2 implies uj plus h into f of tj plus theta h, theta value 1 by 2, u of tj plus h by 2, u of tj plus h by 2. Equation 3 let us take. Here tj plus h by 2 is not a nodal point, is not a nodal point. Therefore, how to evaluate this? Let us evaluate. And what is this function? Okay, from the differential equation, we have u dash t is nothing but what? F of t comma u. This implies f of t comma u is nothing but what? U dash t, right? Now what is my function on the right side? U of tj comma uj is nothing but this one. Tj comma uj is nothing but u dash of tj. So f of tj plus h by 2, u of tj plus h by 2 is nothing but what is this? U dash of tj plus h by 2, right? Therefore this in place of tj uj, if I write tj plus h by 2, then what is this? U of tj plus h by 2, u dash of tj plus h by 2. Now use the approximation, what is that approximation? For u dash of tj plus h by 2 as 1 by 2 of u dash of tj plus u dash of tj plus h. 1 by 2 of u dash of tj and u dash of tj plus h. But what is u dash of tj? U dash of tj is nothing but what? F of tj comma uj plus. Similarly, what is this? Becomes f of tj plus 1 comma uj plus 1. Understood? T of uj, tj uj and u dash tj plus h. Tj plus h is nothing but u dash t j plus 1. So I have j plus 1. Now this implies 1 by 2. There is no change in the first term, plus, right, f of tj plus 1, and approximate this uj plus 1 by using Euler's formula, that is uj plus h into f of tj uj, right? Do you remember? Uj plus h into fj. Approximate uj plus 1 by Euler's method. Okay, approximate this one by this. Then therefore equation, what is that equation? Equation 3, I think 3 becomes, equation 3 becomes, what is that? uj plus 1 is equal to, uj plus 1 equal to uj plus h by 2. You will get the first term tj comma uj plus f of tj plus 1 comma uj plus h into fj, uj plus h into fj. Take this as 4. Now set, to simplify this formula, set k1 equal to h into fj. H into fj means f of tj comma uj, and k2 equal to h into f of tj plus 1 comma uj plus h into fj, that is equal to h into f of tj plus 1 comma, what is h into fj? K1 value. Therefore this is uj plus k1, uj plus k1. Then 4 implies what? 4 becomes uj plus 1 equal to uj plus h by 2 into, what is the first one? Not h by 2, 1 by 2. 1 by 2 of h into this first one. H into this first one is what? K1 plus next one h into this total part. H into this second part is what? K2. K2. H into this K2 is called Euler Cauchy method or Huygen method or Runge Kutta second order method. Runge Kutta second order method. Okay, remember this formula K1 plus K2, where what is K1? How to write K1? H into f of Tj comma Uj, simple logic. And what is K2? H into f of Tj plus H and Uj plus K1. That's it. This is the formula. Okay, this is the main formula, and where K1 and K2 are given by these two expressions. Now, for the initial value problem, u dash t equal to f of t comma u with the u of t naught equal to u naught. U naught t naught equal to u naught. I am giving the method. First, just formula, no need of derivation. Modified Euler Cauchy method. Modified Euler Cauchy method. What is the formula? Uj plus 1 equal to Uj plus K2. Uj plus K2, where K1 equal to h into f of Tj comma Uj. K2 equal to h into f of Tj plus h by 2 comma Uj plus K1 by 2. Uj plus K1 by 2. Uj plus K1 by 2. This is what is the method? Modified Euler's method. Modified Euler's method. And next one, this is another one, Runge Kutta fourth order method. All you know this in degree. Runge Kutta fourth order. Runge Kutta fourth order method. What is the formula? Uj plus 1 equal to Uj plus 1 equal to Uj plus 1 by 6 of capital K1, 2K2 plus 2K3 plus K4. K1, K2, K3, K4 are called Runge Kutta coefficients, where first K1 is h into f of Tj comma Uj, and K2 is h into f of Tj plus h by 2 comma Uj plus K1 by 2, and K3 is h into f of Tj plus h by 2 Uj plus K2 by 2, and K4, it's different now, h into Tj plus h only and Uj plus K3 only. Okay, this is Runge Kutta fourth order method. Mostly the problem will come in this formula. Now problems based on Runge Kutta methods. Given initial value problem, u dash equal to minus 2t u square with u of 0 equal to 1. Estimate u of 0.4 using first question, modified Euler Cauchy method. Modified Euler Cauchy method. Second one, Huygen method. Huygen method is nothing but what? RK, Runge Kutta second order method. Runge Kutta second order method with h equal to 0.2. compare the results with the exact solution. Compare the results with the exact solution. U of t equal to 1 by 1 plus t square. 1 by 1 plus t square. First case, what is that? Modified Euler Cauchy method. Modified Euler Cauchy method. Here u dash equal to minus 2t u square with u of 0 equal to 1. Therefore, what is f of t comma u function? Minus 2t u square, and t naught value is what? 0, and u naught value is what? 1. This is u of 0 equal to u naught. One thing over. The formula is, what is the formula? Modified Euler's form Cauchy, uj plus 1 equal to uj plus k2. uj plus k2, where k1 equal to h into f of tj comma uj, and what is k2 equal to h into f of tj plus h by 2 uj plus k1 by 2. So first let me consider h value is given as, what is this? 0.2. okay, 0.2 into what is this? Is tj uj. So what is the function f? This is the function. So minus 2 tj uj, minus t uj tj uj square, so finally this is minus 0.4 into tj uj square. And coming to this, what is this? 0.2 into minus 2 in place of t, what is the value? tj plus h by 2 into uj plus k1 by 2, this one whole square, and what is h? 0.2. Therefore, what is k2 becomes minus 0.4 tj plus 0.1 you will get, and uj square, uj plus k1 by 2 square. This is k2, right? First one. Therefore, for j equals to 0, equation 1 implies what? u1 equal to u0 plus k2. Why k1 is required? To get k2 I need k1. Where, what is the first k1 value? Minus 0.4 t0 u0 square. So this is 0. And what is k2 value? Minus 0.4 t0 plus 0.1 u0 plus k1 value is what? 0 square. So what is this? k2 becomes minus 0.04. Therefore, u1 equal to u0 1 plus minus 0.04. This is 0.96. What is u1? Is nothing but, u1 means what? u1 is nothing but u of t1. Okay, I will write like this, u of t1, that is 0.2. t0 is 0, h is 0.2. Therefore, what is t1? 0.2, and what is t2? 0.4. Required is up to 0.4. So u of 0.2 is 0.96. This is over for j equals to 0. Now for j equals to 1, equation 1 implies, what is this? u2, the original required u of 0.4, u1 plus k2, where k1 equal to minus 0.4 t1 u1 square, minus 0.4 t1 is 0.2, and u1 is what? 0.96 square. So this is minus 0.073728, and k2 is what? Minus 0.4 t1 plus 0.1 plus 0.1, and this is u1 plus k1 by 2 square. Substitute all the values and simplify. you will get K2 as minus 0.102262. Now second case, Huygen method. Huygen method or Runge Kutta second order method. Runge Kutta second order method. What is the formula is uj plus 1 equal to uj plus 1 by 2 k1 plus k2. K1 plus k2 where k1 is h into f of tj comma uj and k2 is h into f of tj plus h uj plus k1. So what is this becomes? My h is point after substituting f and h, this is tj uj square like previous problem, and coming to this minus 0.4 tj plus h, t value in place of t, this is what, minus 2 t u square. So in place of t this, and in place of this uj plus k1 square, uj plus k1 square. Now for j equals to 0, for j equals to 0, what is this k1? K1 equal to minus 0.4 t naught u naught square 0, and k2 is minus 0.4 t naught plus 0.2 u naught plus k1 square, u naught plus k1 square minus 0.08. Therefore 2 implies u1 equal to u naught plus 1 by 2 0 plus minus 0.08. So this value is 0.96. This value is 0.96. Therefore u1 equal to u of 0.2 is 0.96. 0.96. Now coming to u2, u2 equal to u1 plus 1 by 2 k1 plus k2, where k1 equal to h into, okay, no need of this, shall I write directly, k2 equal to yes sir, k1 equal to minus 0.4 t1 u1 square, minus 0.4 u1 square, this is minus 0.073728, and k2 equal to minus 0.4, this is t1 plus 0.2, this is for j equals to 1, and u1 plus k1 square, and substitute all value, you know k1 value also and u1 value also, you know this value is 0.125676, 0.125676. Therefore u2 equal to 0.96 u1 1 by 2 0.073728 plus minus 0.125676, that is u2 equal to u of 0.4. U of 0.4 is 0.860298, 860298. And what is the exact solution? Compare with exact solution is given. From exact solution, u of 0.2 value is 0.961538, and u of 0.4 0.862069. Therefore modified Euler-Cauchy method, error at the point 2 is 0.001538, and error at point 4 is 0.004331, and Huygen method, Runge Kutta method, epsilon of point 2 is 0.001538, and epsilon of point 4 is 0.001771. So which is a better method? Runge Kutta second order method is better one. Now one problem based on Runge Kutta fourth order. solve the initial value problem. Same problem, solve the initial value problem. U dash equal to minus 2t u square with u of 0 equal to 1 with h equal to 0.2 on the interval 0, 0.4. Use the fourth order classical Runge method. Compare with the exact solution. U of t equal to 1 by 1 plus t square. U of t equal to 1 by 1 plus t square. Solution. Here, what is f of t comma u minus 2t u square? T naught value 0, so u naught value 1, h is 0.2, therefore t1 is 0.2 and t2 is 0.4. So I have to calculate up to u2. Okay, now first let us write Runge Kutta formula. The Runge Kutta fourth order formula is u1. If I write u1, u0 plus 1 by 6 into k1 plus 2k2 plus 2k3 plus k4. I'm substituting j equals to 0 directly in the formula. So u1 formula, where 1 by 1 h equal to where k1 equal to h into f of t naught comma u naught. So 0.2 into minus 2 t naught u naught square, that is t naught is 0. K2 equal to h into f of t naught plus h by 2 u naught plus k1 by 2. So minus 0.2 into this 2 into in place of t, this is t naught plus h by 2 into u naught plus k1 by 2 whole square. Substitute every value and you will get minus 0.04, and k3 value h into f of t naught plus h by 2 and u naught plus k2 by 2. So as usual, minus I have taken outside anyway. Minus 2 into t naught plus h by 2 and u naught plus k2 by 2 whole square, that is equal to k2 by 2 whole square, and substitute every value. This is 38416, and the last value k4 equal to h into f of t naught plus h u naught plus k3, that's all. So 0.2 into t naught plus h multiplied by, okay, minus 2 is there, and a u square u naught plus k3 square. So this value is minus 0.0739715. Therefore u1 is nothing but u of 0.2 equal to this u naught plus 1 by 6 of k1 plus 2k2 plus 2k3 plus k4. Substituting every value, this is 1 by 6, k1 value 0 plus 2 into k2 value 2 into 0.04 plus 2 into k3 value 0.038416 plus minus 0.0739715. So this entire value, this u1 equal to, after simplification, this is 0.9615328. Now u2 equal to j equal to 1, u1 plus 1 by 6, same formula. There is no change in the formula, general formula, but the quotients are changed, where k1 is h into previously f of t naught comma u naught. Now t1 comma u1, this is 0.2 minus 2 t1 u1 square. Now u1 value is here, right? And substitute every value, you will get minus 0.0739636. Here I am giving t1 is 0.2, u1 is 0.9615328. Next, k2 is h into f of t1 plus h by 2 u1 plus k1 by 2. So this is 0.2 minus 2 t1 plus h by 2 u1 plus k1 by 2 whole square, right? After simplification, 0.1025753, and k3 value h into f of t1 plus h by 2 u1 plus k2 by 2. So this is 0.2 minus 2 t1 plus h by 2 u1 plus k2 by 2 whole square. This is equal to k3 minus 0.0994255, and k4 is h into f of t1 plus h u1 plus k3. So 0.2 into minus 2 t1 plus h u1 plus k3 whole square. This is a value minus 0.1189166. And the last is, therefore u2 equal to u1 plus 1 by 6 k1 2k2 2k3 plus k4. Thus, and substituting entire value, u1 0.9615328 plus 1 by 6 of, substitute all these values. Okay, 1 2 3 1 2 3 plus 4. Okay, and simplifying, u2 is nothing but u of 0.4, that's value 0.8620525. okay, now error, compare with the exact solution. Now absolute errors in the numerical solution, solutions are at 0.2, 0.9639 minus 0.961533, exact minus approximation 506, and error at 0.4, 0.862069, this is exact value, and approximate value 0.862053 I can take 53.4016. okay, with this Runge Kutta methods finished, and I will give some more problems, worked out problems. Okay, and I will WhatsApp you more number of problems in Euler's method and Runge Kutta methods.